So here in question 49, we want to find something called a difference quotient. So it's a quotient and it involves a difference. We're considering cases here where h is not equal to 0, so we're not dividing by 0. So here's our function. And what we want to do is, instead of putting in x, here we want to put in x plus h. So let's see what that looks like first. So f, put in x plus h. Well, what I like to do is I like to write empty parentheses where I'm going to put the x here. So our f of x is 2x squared minus x plus 9, or where I'm going to put the x plus h. So I can write this as 2 times parentheses squared minus parentheses plus 9. And what's going in the parentheses is the x plus h instead of x. So all the way across. And then we want to simplify this as much as possible, and then we'll plug it into this equation. So x plus h squared, that's going to be x plus h times x plus h. And then minus, we could distribute that minus sign here, minus x minus h plus 9. So first terms here give x squared. So this will be 2 times x squared. Outer terms xh, inner terms xh, so 2xh. And then last terms h squared. And then carry along minus x minus h plus 9. So now we need to multiply the 2 in, distribute it in, times each term. So 2 times x squared, 2x squared. 2 times 2xh, 4xh. And then 2 times h squared, 2h squared. Minus x minus h plus 9. And we have combined all our like terms. So now we'll plug it into this equation. So now we're going to form this difference quotient here. So on the top, we've got this f of x plus h, which is right here. We simplified it. So we'll have 2x squared plus 4xh plus 2h squared minus x minus h plus 9. And then we're going to subtract off our original f of x right here. 2x squared minus x plus 9. And that's got to be in parentheses. And then all over h. So we're subtracting something in parentheses here, so we can change the signs and add. So change this to addition. This will be negative 2x squared, positive x, negative 9. And then all three of these should cancel out. Negative 2x squared and positive 2x squared cancel. Positive x and negative x cancel, they add to 0. Positive 9, negative 9, they cancel, they add to 0. So what do we got left? 4xh plus 2h squared, and then minus h all over h. And then notice we got a common factor of h in here that we can factor out. So that's our next step. So we'll factor out an h. Here we'll have the 4x left. Here we'll have 2h left, because 1h is gone. And then factor out the h there, we'll have minus 1. And then we're dividing by h. and the h's cancel. So we've got 4x plus 2h minus 1. So I encourage you to write out the f of x plus h separately, simplify it all, then plug into your difference quotient. The whole function f of x should cancel out. And then in the next step, you should always be able to factor out an h to cancel the h in the bottom. So now try, pause the video and try real-time quiz 34. So next up here, we're given some functions. F of x is x minus 1, g of x is 4x squared, and we're going to do some arithmetic operations with them. So we want to write an expression here for f plus g of x, f times g at x, and f minus g at 3. So, well, the definition of f plus g at x, this just means take f of x and add g of x. So you just add the two equations up here and combine like terms. So we've got x minus 1 is your f of x, plus 4x squared is your g of x. Don't have any like terms to combine in there. That's just 4x squared plus x minus 1. F times g at x is defined to be f of x times g of x. So we just multiply the two equations. So this will be x minus 1 times that 4x squared. So we'll just have to multiply that 4x squared in. So 4x squared, that's a parenthesis. 4x squared times x, 4x cubed. 4x squared times negative 1 minus 4x squared. So that one's simplified. F minus g at 3. Well, this one means compute f at 3 and then subtract g at 3. So f plug in 3 will be 3 minus 1. So this is going to be 3 minus 1. And then we're going to subtract g plug in 3. So 4 times 3 squared. So 3 minus 1 is 2, minus 3 squared is 9 times 4, 36. And 2 minus 36 is negative 34. So they'll have you do something similar to that in ALEKS, arithmetic operations. Now there's one we haven't done. We did addition, subtraction, multiplication. We haven't done division here yet. And they do that in example 51. So your f of x is 4 plus x times 4 plus x, which is really 4 plus x squared. Your g of x is negative 5 minus x. They want us to find f divided by g at negative 6. And this is just defined to be f plug in negative 6 minus, divided by g plug in negative 6. So f plug in negative 6, we'll plug it in here and here. So we'll get a 4 minus 6 times 4 minus 6. And then we're dividing by negative 5 minus negative 6. Double negative there. It's negative 5 minus, and our x is negative 6. So let's see here. 4 minus 6, that's negative 2. So this is negative 2. And then 4 minus 6 again is negative 2. Negative 2 times negative 2 is positive 4. Negative 5, double negative here, makes it positive. Negative 5 plus 6 is 1. That's just 4. And then they ask us, find the values that are not in the domain of f divided by g. Okay, well, that means f divided by g at x, okay, which means look at f of x divided by g of x, that equation. So your f of x on top is going to be 4 plus x times 4 plus x, which is really 4 plus x squared. And then your g of x is the negative 5 minus x. Well, the top is just a polynomial. It's always defined. But the bottom, whoops, I wrote a square there. I don't want a square. Negative 5 minus x. So the top is a polynomial. It's always defined. But the bottom, it can't be 0 because you can't divide by 0. So what you're going to do is you're going to take and set your negative 5 minus x equal to 0. Let's go ahead and bring that x over as a positive. So negative 5 equals x. So negative 5 is not in the domain. So it says, find the values, list them with commas. Well, there's only one. Negative 5. That's our final answer. So that's arithmetic operations. And then the last operation you can do with functions is composition. So here they give us functions q and r. Q is negative 2x minus 1. R is x squared minus 2. They want us first to find r of q of 4. So let's see here. R of q of 4. Okay, so this means, do the inside first here. The q plug in 4. So q plug in 4 is going to be, we're using this equation, negative 2 times 4 minus 1. So that's negative 8 minus 1, negative 9. And then that's what this inside is right here. That's negative 9. So you work from the inside out. So now this is r plug in negative 9. And let me move this out of the way here. And then what is r plug in negative 9? Well, we put a negative 9 in here for x. So that's going to be negative 9. That quantity gets squared minus 2. So negative 9 squared, 81 minus 2. So what is that, 79? So that's composition at a number. They could also ask you to do just like the composition of the two functions. So that would be something like this. Q circle r of x, which is q of r of x. And again, you work from the inside out. Your r of x is right here, x squared minus 2. So this is q, and then you're plugging in x squared minus 2. So, and then I like to rewrite the outside function with empty parentheses. So replace your x here with just empty parentheses. So q of parentheses equals negative 2 parentheses minus 1. What are we putting in the parentheses? X squared minus 2. So that goes here. And now we can do a little bit of simplifying. The negative 2 can come in like this. So that's what? Negative 2x squared. Negative 2 times negative 2, positive 4. And then minus 1 on the end. So 4 minus 1 is 3. Negative 2x squared plus 3. And then we could switch them around. So we could also do r circle q plug in x. And that will not be the same thing. That's r plug in q of x. So that's taking the function r, and you're plugging in the equation for q of x, which is at negative 2x minus 1. So r plug in negative 2x minus 1. And then, again, rewrite your outside function with empty parentheses. What does r do to x? It squares it minus 2. So this will be parentheses squared minus 2. What are we putting in parentheses? Not x. This whole thing, negative 2x minus 1. And then we could FOIL this out, subtract 2, collect like terms, but it's a different function. So you just do them in same order. R circle Q is R plugin Q of X. Q circle R, Q plugin R of X. So that's composition. And then let's see here. They have us do a couple more evaluating here. So Q circle R at 8. That is going to be Q plugin R of 8. So you do the inside first, R plugin 8. We'll do that over here. So R plugin 8, that's right here. So you put an 8 in there. That's going to be square root 8 plus 8. That's root 16, which is 4. So this inside is 4. So now this is Q plugin 4. And the function Q does x squared plus 9. So this will be 4 squared plus 9. So 16 plus 9, 25. Let me move this guy over a little bit. So that's 25. R circle Q of 8. So that means R plugin Q plugin 8. That's composition the other direction. So Q plugin 8, here's our Q. So let's do that over here. So Q plugin 8 is going to be 8 squared plus 9. So that's 64 plus 9, 73. So this inside here is 73. So what is R doing? It takes square root of whatever you plug in plus 8. So this will be square root 73 plus 8, which is 81, square root of 81, and that's 9. 9 is the number you square to get 81. So that's arithmetic operations and compositions. And with that, you can try quiz 35. So pause the video and do that real quick. And then last example. Here they give us a function, cube root 4 minus 7x. They want us to break it down as a composition in f circle g of x. So they want us to write it as an f of g of x. So you've got an inside function here and an outside function. And that's the easiest way to see how to break them up. So your inside function here is 4 minus 7x. That's going to be your g of x. So that's your g. And then your outside function, what gets done to that 4 minus 7x is the cubed root. That's going to be your f. So start by doing the inside function. So the inside function is g of x equals 4 minus 7x. And then the outside function, f of x, what does it do to that 4 minus 7x? Well, it takes the cube root of it. So cubed root, and we replace the 4 minus 7x with just an x. So that's how you would break down that composition. That's all they're asking for there. So not doing computing, just breaking it down. And sometimes there's more than one way to break down. All right, that's everything for today. So you should be able to do section 2.8. That is coming due for Friday.